Hello everyone, and welcome to Tech with Robert. Get started with T-SQL course. In this lecture, we're going to continue talking about joins. In this case, the self join. But before we get started, don't forget to subscribe to my channel. Give a thumbs up on the video if you like what I do. That really helps me to know what I do well and what you guys want me to improve on or focus more on in the future lectures. So without further ado, let's dive right in and talk about self joins. And so a self join it's not a join on its own, like it doesn't have its own syntax. Like if I were to write select star from table person and name it person, I could not write self join instead of left join here. So the syntax self join does not exist. It's merely a theoretical concept on how you can apply the power of joins to perform a special kind of join, which is the self join, if that makes sense. I'm going to explain that in a lot more detail, but consider this table here, right? We have a table called table person, and in that table we are storing information. Each person has a person ID, a name, and the ID to a friend. Okay, and so consider this case here. So let's say that we have the sales table, which we've been working a lot with recently, and in that table we have a lot of different columns of values to represent a sales transaction. And so in that specific sales transaction, we're storing things like the sales transaction date, the number of products, the actual product, and the customer who perform that sales transaction, but we don't store any information about the actual customer. So we only use the customer key to tie a customer to a sales transaction. But if you want to look at information about the actual customer, that information is not stored in the sales table, it's stored in the customer table. But so if we take it like this, we say person name Robert. If I just say Robert, I don't have enough information with only Robert to model a sales transaction, right? But if I say Robert, I could say that, okay, Robert is a person, right? And I can also say that Robert is a friend. I could also say that Robert is a customer or a department manager, he's a sales manager or manager, boss, chef, whatever. So I can use, my point is that I can use this value Robert, and that is enough to represent multiple things like a person and a friend. And in some scenario, this is actually a very common scenario when you work with database projects where they store employee information. So it's very common that you store the employee names, and then so even all of the managers are stored in the same table. And so you have a employee or like a manager ID to represent who each employee's manager is. But all of that information is stored in the same table. So we don't have one table that's called dim employee and then we have another table called dim manager, for example, because we have all that information. It can represent all of these multiple things, and so we store that in the same table. And so in this case we have person ID 1, and the person name is Robert, and then we have the friend ID of 2, and the information about this person with person ID 2, a friend ID 2, is stored in the same table. So in this case it's Mike, because Mike has person ID 2 and the name Mike, and here I say that Robert's friend is the person number 2, which is Mike. So instead of dividing and splitting these up to multiple tables, we have all of these values that can represent multiple things, in this case a person, customer, employee, friend, or whatever. So we have all of that information stored in the same table. And so when we do a self join, because if I wanted a query where I wanted to display every person's ID, the person name, and the name of the actual friend, in this case Mike, I would have to perform a self join. And a self join is basically just you specify a table that you want to select the information from, and then you perform a join. In this case, I performed a left join, but you can perform inner join or right join or whatever type of join you want to. So there's no individual type of join. So you cannot, as I mentioned earlier, you cannot write self join because that is not valid. So it's just a regular join, but the difference here is that instead of, for example, saying we want to select everything from table sales and then we want to join to the table customer, we are getting the information from table person and we're performing a join to the same table. And in the previous lecture, I mentioned that I usually don't use the alias and long names for my aliases here. But in this case, when I use self joins, I like to be more specific, because when we just say that we select from the table person, this table here represents a person. But the same table, because we do a left join to the same table, but this table is representing a friend. And I know that, like, if I were to name it P and F, people could understand that, okay, but F is short for friend. But in these cases with self joins, I like to be more specific, because in this case, this join here, that very same table is now playing two different roles. The first role is just a person, and the second role that it plays is a friend. And so we can use this and we can join on the person's friend ID. It's going to match the friend's person ID. So in this case, we're saying, okay, give me the person ID, person.name, and I'm giving an alias to person name, because from the friend table here, the alias, we still have the same name of every column, right? So here I would like to have an alias, because otherwise it would just say name, and we wouldn't know which one is which. So in this case, I like to be more precise, And so if we take a look at the friend.name here, we are saying that we want the person.friend ID is going to be equal to the friend.person ID. So what that does is it's saying here, okay, person ID 1. So from the person, we're saying friend ID 2. It's going to be equal to the friend's person ID. So it's saying 2, and it's joining it with 2, and therefore get the value person name Mike here. Then it goes on to the next one. It says person ID 2. It's going to be the friend ID 3. It's going to be the friend's person ID. So here it's 3, so it puts James there. And so I'm going to show you how to write this query. And I have prepared a small script here for storing these persons. I will link it in the description below. I just use this for this lecture if you want to follow along hands-on. And so consider this query here. We're just going to say, okay, I like to always, just select everything from that table that I'm going to work with, so I can see sort of the value. So I say, okay, we have person ID 1, 2, 3, 2, 5. We have different names here, and I have a field here called friend ID that represents which person is friends with who. And so if I now wrote a query like this, I would say I give it an alias that person, because this is going to represent the actual person. And then in this case I do an inner join to the very same table, but in this case this table is going to represent the friend, so I'm giving it an alias to friend. And the join condition is the person's friend ID, it's going to match the friend's person ID, like this. So now we can say that we want to select the person ID, and then the name from the person table, and I will give it an alias as person name, right? And then I want the person.friend ID and the friend.name, and this is going to represent the friend name. And so watch what happens here. I did an inner join here, and as we can see now we have 5 customers, but when I run this query we only get 4 rows. And by now I expect that all of you who watched the previous videos knows why we only get 4 rows here. It is because in an inner join we say that we want to select all of the rows where there is a match on the table on the left side and the right side, and these 4 rows are the only ones that match that criteria. If I change this to a left join, we'll get all of the values. But since Tyler didn't have a friend, we cannot possibly assign a name here because we don't know. It could be that he doesn't have any friends or it's just not specified, but here it just says null, so we don't know anything about his friends here. And so just to recap, that a self join is just a join from one table to itself, to the same table. But when you perform a self join, that very same table is going to play different roles. And so in this case we have the original table here, person, it represents a person. And then when we do the left join to the same table to itself, self join, it's representing a friend because we're using the friend ID here. I hope you guys understand now what a self join is, how to write it, and I hope that you all understand now the different types of joins that we have covered and been discovering. The inner join, left and right join, the full outer join, and the self join. Because in the next lectures or upcoming lectures, I want to talk more in depth about join conditions and why we sometimes need to join on more than one field. Because here we have, up until now, we have worked with joins, but we have said in the on clause here, we have only selected one field from the left table is going to match one field from the right table. But sometimes you need to match on multiple fields. So we could say person ID, friend ID is person ID, and this ID is equal to this ID, and maybe this, another one, because otherwise we will get more than one row or missing out on rows. So that is what I want to talk about in the future lectures. And I also want to show some more advanced queries with joins, because it's very unlikely that in a big database or data warehouse project that you select something from one table and then you just do one join to one table, because in real life you could have 20 or even 50 joins. You extract data from 50 different tables. So that is why I ordered the lectures in this way, because I really want you guys to understand all of the different joins and how they work, because it's going to be very difficult to continue on more advanced concepts if you don't understand these fundamentals. And the reason why I'm repeating myself a lot, and I want to apologize for that, but the reason why I'm doing that is because when I learned SQL, I had a pretty brief understanding of all of the joins, but I didn't really fully understand every join in depth. So then when I got into some database projects, I was struggling a bit because there were so many joins here, and sometimes I could find that there was let's say there were 20 joins, and the reason why there was a bug in the query was because the 7th join was an inner join instead of a left join, and all of these things. So it took a lot of time and a lot of troubleshooting to find that error. And the reason was that I didn't knew the tips and tricks. Well, first of all, I didn't know the tips and tricks on how to find these join bugs. I'm going to show that in a later lecture. But the second reason was that I didn't really fully understand the different type of joins. So that is why I don't want to show you some more advanced queries with a lot of joins before thoroughly talking about the fundamentals of joins. I think that is a really, really important concept, and it's going to make your SQL life or career a lot easier, believe me. So as I said, in the next lecture we're going to talk more in depth about join conditions and why we sometimes need to join on more than one field to avoid duplicate rows. That is it for this lecture. I will see you guys in the next lecture.